For this example, on this example, I want to use the graph to determine the domain and range of the function. We're given a picture of the function, and from this picture, we want to state the domain and range. A very common mistake for finding the domain in a question like this is to take a look at these ordered pairs that are labeled on the picture and list the x's as the domain and list the y's as the range. Now, the reason why that is incorrect is because when we find the domain, we're trying to find all of the x's. And if you list out just these numbers, you're only getting the domain for those individual points. So we're going to use interval notation, and interval notation will allow us to get all of these values instead of just these individual ordered pairs. So we're going to find the domain. And when I'm finding the domain from a graph, I like to use a pencil or a ruler, and I hold that ruler vertically when I'm finding the domain. And I'm holding it vertically because holding it vertically is pointing to your x scale. So I'm going to start from the left and move to the right. And I'm starting on the left because the left is where your x values are lowest. We always write interval notation lowest to highest. So I'm starting on the left, and I'm going to figure out where my domain starts. And I figure that out by when my ruler hits the graph the first time. So right here, my ruler is hitting this point right here. That point has an x value of -9, so that's when my domain will start. If I continue moving to the right, I can see that my ruler is touching the graph. The last time that my ruler touches the graph is at this point right here, which has an x value of 4. So that's where my domain will stop. Now, interval notation uses parentheses when the number is not included in the set, and brackets when the number is included in the set. So you can see that this ordered pair has an open circle, which means that point is not part of the graph, and -9 should not be part of our domain. So we're going to use a parenthesis. However, this point has a closed circle, and the closed circle is part of the graph and is part of the domain. So we're going to use a bracket on the 4. So we have the domain being -9 to 4, not including -9, but including 4. Then we're going to find the range. And with the range, I want to hold my ruler horizontally because that will point to the y scale. And we're going to start at the bottom and move to the top. The bottom has the lower y values, the top has the higher y values. So the first time my ruler hits the graph is at this point, and this point has a y coordinate of -10, so that's when my range will start. Continuing on up, I'm touching the graph, so all of these values are part of the range. The last time my ruler hits the graph is at this point here, which has a y coordinate of 6. So once again, interval notation uses parentheses when the value is not in the set, and brackets when the value is in the set. So because this point has an open circle, that point is not included in the graph, and we should not include it in the range. This point has a closed circle, and it is included in the graph, and we should include it in the range. So just before we wrap this question up, I want to make sure you understand what this interval notation actually means. So with the interval from -9 to 4, this is x values, and we're going to mark -9 on your number line and mark 4 on your number line. We're not including -9, we are including 4, and we're going to shade the values between these. So this interval notation doesn't just represent the two numbers that we've written down, it's all of the numbers between those two. And then when we use the parentheses and the brackets, it tells us whether we're including the endpoints or not. For the second one, this is on our y scale, and we're going to mark -10 and 6 on our number line. -10 is not included, but 6 is, and we shade between. So this interval notation, -10 to 6, is including all of the numbers between -10 and 6, but not -10 and yes to -6 being included. So this is the question in my math lab, so I thought we would just go ahead and type the answer. So what we saw is that our domain started at -9 and went all the way until 4. We're using a parenthesis on the -9 because of this open circle. So I'm using my keyboard to type parenthesis and -9. Then I'll do a comma. And the domain continues until 4. And I'm going to use a bracket because of this being a included circle, a closed circle, and I'm using the keyboard to type the bracket, and we've got that one correct. And for the range, we're looking at the y values, so we start with the lowest y value of -10. And this is an open circle, so that point will not be included. So I'm going to use a parenthesis from my keyboard. That's a -10, comma, and the highest y value here is a 6. This point is closed circle included in the graph, so we're going to use a 6 with the bracket from the keyboard. On this example, we want to find the center, radius, and intercepts of the circle with the given equation, and then sketch the graph. The equation that we're given is 2x squared plus 2y squared minus 8x plus 12y plus 8 equals 0. So this is an equation of a circle that is in general form. And this format is not the best format for us to figure out the center and the radius. What we'd rather have is the equation in standard form. In standard form, the equation of the circle looks like this: x minus h squared plus y minus k squared equals r squared. And HK is the center of the circle, and R is the radius of the circle. So what we're going to do is we're going to change the equation from general form to standard form so that we can answer these two parts, the center and the radius. With standard form, what we want to do to work towards standard form, first I'm going to notice these coefficients on the squares. I want to get rid of those, and luckily all of the numbers that we have in this example are all even numbers, so they're all divisible by 2. So I'm going to start by just dividing every term by 2, and that gives me a new equation in general form, x squared plus y squared minus 4x plus 6y plus 4 equals 0. And then what I want to do is have a group of x's and a group of y's. So I'm going to take the x terms and group them together to be x squared minus 4x, and take the y terms and group them together. That would be y squared plus 6y. And I want to move the constant to the other side, so I'll subtract 4 on each side. Now, I want to group in the x group. I want to make a little bit of extra space for another term in that group. In the y group, I want to make a little space for an extra term in that group. And what we're going to do is something called completing the square. With completing the square, we're going to figure out what that extra term is that we're going to add. And we call that extra term, well, I like to call that extra term the magic number. The magic number is what's going to make everything work out, make it look nice. So the magic number for the x's, we got to figure out what that number is. We start with the coefficient on the x term, -4. And we're going to cut it in half and square it. -4 divided by 2 is -2. -2 squared is 4, so our magic number for the x group is 4. Very similarly, I want to find the magic number for the y's. So I'm going to start with the coefficient of the y, 6. Same process, cut it in half and square it. 6 divided by 2 is 3. 3 squared is 9. So our magic number for the y group is 9. I want to add these magic numbers to the x group and the y group, but you're not allowed to just add any number you want anytime. You have to balance the equation. Whatever you do to one side, you have to do the same thing to the other side. So we want to add that 4 to the x group, but we have to balance the equation by doing the same thing on the other side. We want to add the 9 to the y group, but we have to balance by doing the same thing to the other side. So now that we've added that magic number, we're going to be able to factor the x group. We have a trinomial, and that trinomial will factor into 2 binomials. X times x gives me x squared, the first term. 2 times 2 gives me 4, the last term. And when you multiply the inside, you would get 2x. and the outside you would get 2x. We need to add those together to get negative 4x. So let's make these negative. And now we have negative 2x and negative 2x adding to be negative 4x. You see that not only were we able to factor this, but the two binomials are the same, x minus 2. So that means that we can write this as x minus 2 squared. The same thing happens with our y group. We have a trinomial. Y times y will give me y squared, the first term. 3 times 3 will give me 9, the last term. We multiply the inside, we get 3y. The outside, we get 3y. 3y plus 3y will give me 6y. And not only does it factor, but you can see those two binomials are the same. Y plus 3 times y plus 3 is the same thing as y plus 3 squared. On the right-hand side, we'll combine like terms. Negative 4 plus 9 is 9. And now we've written this equation of a circle in standard form. And now that it's in standard form, it's easy to identify the center and the radius. The center is 2, negative 3, with a radius of 3. And we also want to find the x and y intercepts of this circle. You're going to find an x-intercept by letting y equal 0. So let's do that with our standard form. So I'll do the standard form and find the x-intercept by letting y equal 0. So that would give the equation x minus 2 squared plus 0 plus 3 squared equals 9. And we'll simplify inside the parentheses. 0 plus 3 is 3. 3 squared is 9. And I'll subtract 9 on both sides. We have x minus 2 squared equals 0. I'm going to get rid of that square by square rooting. The square and the square root cancel each other out, leaving you with x minus 2. We gain a plus or minus symbol on the other side. The square root of 0 is 0. I'm going to add 2 to both sides, and we get x equals 2 plus or minus 0, and that's really just the number 2. 2 plus 0 is 2, 2 minus 0 is 2. So we just have one x-intercept, and that's 2, 0. We're going to find the y-intercept by letting x equal 0. And let me write down, this time I will find the y-intercept using our general form. So our original equation was 2x squared plus 2y squared minus 8x plus 12y plus 8 equals 0. So if I'm looking for the y-intercepts, I'm going to let x equal 0. That's 2 times 0 squared plus 2y squared minus 8 times 0 plus 12y plus 8 equals 0. So this term becomes 0, this term becomes 0. We have the equation 2y squared plus 12y plus 8 equals 0. I can do that trick that I did earlier. All of these numbers are even, so I can divide out that coefficient. That makes this equation a little bit nicer. We have y squared plus 6y plus 4 equals 0. And I can try to factor this, but I don't think that this equation factors. Y times y is y squared. I could do 2 times 2, but that's going to give me 2y and 2y. 2y plus 2y doesn't give me 6, so that's not going to work. I could try, instead of 2 times 2, I can try 1 times 4. That would give me y and 4y. 4y and y make 5y. They don't make 6, so that's not going to work. So this particular quadratic equation does not factor. But we can still solve the quadratic equation using the quadratic formula. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. For this example, a is 1, b is 6, and c is 4. A is always the coefficient of the squared term, b is always the coefficient of the linear term, and c is always the constant. So we get y equals negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 4 all over 2 times 1. And then we'll simplify following order of operations. 6 squared is 36. And we have 4 times 4, that's 16. And negative 6 plus or minus the square root of 36 minus 16. Let's see, that would be 20 over 2. And the square root of 20 can be simplified. 20 is 4 times 5. The square root of 4 is 2. And then we can simplify a little bit more, dividing 2 into each term. So that's negative 3 plus or minus square root of 5. So that would be our y-intercept. We have 2 of them, 0, negative 3 plus square root of 5, 0, negative 3 minus square root of 5. Okay, the last part of this example is to graph our circle. And we're going to graph using the center and the radius. This graph has a center of 2, negative 3. So 2, negative 3 would be here. And from the center, I'm going to go 3 in each direction. So 3 up, 3 to the right, 3 down, and 3 to the left. We'll connect those points in the shape of a circle, and we have the sketch of our graph. What's nice about looking at the graph now is that it confirms what we found earlier, that we have just one x-intercept at 2, 0. And we do have multiple y-intercepts, negative 3 square root of 5, negative 3 plus square root of 5, and negative 3 minus square root of 5. For this example, we want to graph the equation 3x minus 4y equals 8. And we're going to graph it using the plotting points method. Now we are specifically given which x values we want to use. And we want to find the y values, but you can see here at the top of our table, the answer that we want to type in the blank should be an ordered pair. So we need to figure out the y value, and then when we type our answer, we don't just type the y value, we type the whole ordered pair. It also specifies down here to type ordered pairs as our answers. So we have our equation 3x minus 4y equals 8, and we're going to let x equal negative 8. That will give us the equation 3 times negative 8 minus 4y equals 8. 3 times negative 8 is negative 24. So that's negative 24 minus 4y equals 8. I'm going to add 24 to both sides. Negative 4y equals 32. I'll divide both sides by negative 4 to get y equals 8. Negative 8. So in this blank we would type negative 8, comma, negative 8 as an ordered pair. Then we're going to repeat this with x equals negative 4. So then we'll have the equation 3 times negative 4 minus 4y equals 8. 3 times negative 4 is negative 12. We'll add 12 to both sides. This gives negative 4y equals 20. Divide both sides by negative 4, and we get y equals negative 5. So we have the ordered pair negative 4, negative 5. Let's repeat this again with x equals 0. We have 3 times 0 minus 4y equals 8. 3 times 0 is 0. So that gives negative 4y equals 8. And I'll divide both sides by negative 4. And we'll get y equals negative 2. So the ordered pair 0, negative 2. One more time with x equals 4. We have 3 times 4 minus 4y equals 8. 3 times 4 is 12. We'll subtract 12 on both sides to get negative 4y equals negative 4. Divide both sides by negative 4, and we get y equals 1. So we have the ordered pair 4, 1. So then we want to take these ordered pairs and plot them on our graph. So let's plot those ordered pairs of negative 8, negative 8, negative 4, negative 5, 0, negative 2, and 4, 1. Just going to move this so it's not covering up everything. And then we can connect those points with a straight line. Hopefully this is a straight line. Let's see. It should be a straight line. If you don't get a straight line, that means you've probably done some kind of arithmetic error on one of your calculations. You should go back and check your work. We did get a straight line here. And we've drawn the graph of our equation. For this example, we want to graph the equation y equals 2 square root of x by plotting points. And we're given a partially completed table, and we're going to finish filling out this table. We're given some x values, and we want to write the ordered pairs for each one of those x values. So we need to find the y's to complete those ordered pairs. So for the equation y equals 2 square root of x, we're going to let x equal 0. That would give y equals 2 square root of 0. Square root of 0 is 0, so that's 2 times 0, which is 0. Our first ordered pair is 0, 0. Then we'll let x equal 1. That would give the equation y equals 2 times the square root of 1. Square root of 1 is 1. 2 times 1 is 2. So we get the ordered pair 1, 2. Then we let x equal 4. That would give y equals 2 square root of 4. Square root of 4 is 2, and 2 times 2 is 4. So we have the ordered pair 4, 4. And then we let x equal 9. That would be the equation y equals 2 square root of 9. Square root of 9 is 3. 2 times 3 is 6. So we have the ordered pair 9, 6. And then we want to graph this. And I'll plot the ordered pairs that we found. 0, 0, 1, 2, 4, 9, 4, 4, and 9, 6. This is the graph of 2 square root of x. We want to find the standard form of the equation of a circle with endpoints of a diameter at the points 1, 2 and negative 9, 6. So let's start by making sure we know what a diameter is. A diameter of a circle is when you have 2 points on the circle, and when you connect those 2 points, you're going to pass through the center of the circle. So that's what a diameter is. So a diameter goes from one side of the circle to the other side, but it must pass through the center. If it doesn't pass through the center, if it goes from one side to the other, but doesn't pass through the center, we call that a chord of the circle. A diameter will always pass through the center. Now, when you have the endpoints of the diameter, you can use those endpoints to help you find the center and the radius. And the center and the radius are going to be very helpful for writing the standard form of the equation. The standard form is x minus h squared plus y minus k squared equals r squared. So if we know hk, the center, and r, the radius, we will be able to write that equation of the circle. So these endpoints of 1, 2 and negative 9, 6 are going to be helpful in finding that center and the radius. So I'm going to draw a really big circle because it's helpful to visualize what we're going to do here. So we've got 2 points on the circle. Let's say this one is negative 9, 6, and this one over here is the 1, 2. And we know that these are endpoints of the diameter. The center is going to be right in between those 2 points, in the center, in the middle. So if we want to find the center, we can use the midpoint formula. Finding the midpoint is averaging the x values, add up those x values and divide by 2, and add up the y values and divide by 2, and you're going to find the center of the circle. You're going to find the midpoint, which is our center. So our center will be 1 plus negative 9 over 2, comma, 2 plus 6 over 2. If we simplify, 1 plus negative 9 is negative 8, divided by 2 is negative 4. 2 plus 6 is 8. 8 divided by 2 is 4. So we have negative 4, 4 being the center of the circle. We also need the radius of the circle. The radius of the circle goes from the center to a point on the circle. So if we can find that distance, then we'll know the radius. So we can use the distance formula to find the radius. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And I'm going to use the center that we just found in one of the points on the circle. It doesn't matter which point. One of those endpoints. So I'm calculating the distance between the center, negative 4, 4, and one of my endpoints of the diameter, which is 1, 2. And I'm plugging that into the distance formula to get the radius. It's the square root of 2 minus 4 squared. Excuse me, let me go a little bit slower on this. Let's label these points as x1, y1, and x2, y2. So following the formula, x2 would be 1 minus x1, which is negative 4, squared, plus y2, 2 minus y1 squared. We'll simplify to get square root of 1 minus negative, that's 1 plus 4 squared. 2 minus 4, that's negative 2 squared. 1 plus 4, that's 5. 5 squared is 25. Negative 2 squared is 4. So we've got square root of 29 as our radius. So now that we know the center and the radius of our circle, we can write the standard form. That's x minus negative 4 squared plus y minus 4 squared equals the radius squared. And I'm going to simplify two things here. I'm going to simplify this double negative, and I'll simplify the square root of the square. So this is x plus 4. Negative times negative is a positive, times y minus 4 squared. And the square root and the square cancel each other out, giving you 29. For this example, we want to use the graph to answer the questions. What is the y-intercept of our function? And what are the x-intercepts of our function? So first we need to remember what the definition of a y-intercept is. That's going to be where the graph crosses or touches the y-axis. So the y-axis is this vertical axis, and we can see that this curve crosses the y-axis at the point 0, -3. So for part A, what is the y-intercept? We have 0, -3. When you're doing this in your homework, make sure you pay attention to the writing next to the blank, because it looks like in this example they don't want you to write the ordered pair, they just want you to write the y-coordinate as the answer. Then what is an x-intercept? An x-intercept is where the graph crosses or touches the x-axis. So the x-axis is this horizontal axis. So we're looking for places where the graph crosses or touches. Here we have a point where the graph crosses. So that's going to be an x-intercept, -7.4, 0. We have another place where the graph crosses. That's -4, 0. And another place where the graph crosses would be 5, 0. And then this spot right here looks like it touches the x-axis. But if we take a closer look here, you can see that that point is drawn with an open circle. When we draw that point with the open circle, that point is not part of the graph. So we're not going to include that as one of our x-intercepts. So only because that graph is drawn with an open circle is why we don't include it. If it were drawn with a closed circle, that would be a point where the graph touches the x-axis, and we would include that as an x-intercept. So for this example, we would type -7.4, -4, 5 as our x-intercepts. In this example, we want to use the graph to answer the question, for what values of x is f of x less than or equal to 0? So we want to remember what this notation means, f of x. F of x is the same thing as y. So this question is really saying, for what values of x is y less than or equal to 0? So we want to pay attention to our y scale, and we know for our y scale that anything that is on the x-axis, so anything that is on the x-axis will have y equal 0, or f of x equal to 0. Anything that is above the x-axis will have y being greater than 0, or f of x being greater than 0. And then anything below the x-axis will have y being less than 0, or f of x being less than 0. So this question is asking for when y is less than or equal to 0. So we want to write down where the graph is on the x-axis or below the x-axis. That's less than or equal to 0. Let me erase some of these markings so it's not so cluttered. And let's highlight the portions of the graph that we're interested in. So we want all of the pieces of the graph that are below the x-axis. So let's highlight all the pieces that are below. And we also want all of the pieces that are on the x-axis. So let's highlight those. Let's do it in a different color. So on the x-axis would be here, 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 and here. So these are all points that are on the x-axis. We want to include these in our answer. Now, reading the question one more time, it says, for what values of x? So our answer that we give should be values of x. I'm going to bring my ruler out and hold it vertically. When I hold it vertically, I'm pointing to x values. So I'm going to use my ruler to help me write down the x values in interval notation. So the first x that I have highlighted that I reach, when I say first, I mean lowest. When we use interval notation, we always write the lower number first, then the higher number. So the first or lowest x value that I get to will be using this point right here. So we're going to use the x value of that point. -12, that's where my x's start. Now you'll notice that that point is an open circle. So I want to use a parenthesis on that. Open circle means that that point is not included in the graph. And in interval notation, parenthesis is when you're not included in the set. So that's our first x. Use my cursor here. So that's my first x. Then all of these x's are included until I get to this x right here. Now that point has an x value of -23/2. And I want to include it in my set, so I'm going to use a bracket. So remember that I'm including the points that are below the x-axis, and I'm including the points that are on the x-axis. So that's why this point is included, and I'm using a bracket on that point. So then I'm going to go to this section, and the first x that I get to, the lowest x that I get to is -8. I'm going to use -8, and I'm using a bracket. And all of these x's are included until I get to this x here. That's where it stops at an x of 1. And that's also included. Now there's one more point that needs to be included. And this is where we're going to use a different notation. This notation that we used here is called interval notation, and that's where you have a group of points, an interval of points. You can see we have a whole line here that we're including, a starting point and an ending point. Here we have a starting point and an ending point and everything in between. That's when we use interval notation. When we have one point on its own, we can't use interval notation. Interval notation is when you have two numbers and you want to include the numbers in between those numbers. Here we want just a single point. So when we have just a single point, we use curly braces to list that single point. So these are all of the x's that have y's that are less than or equal to 0. And to write it in set notation, we use the union symbol between those intervals. For this example, we want to find the intervals of increasing, decreasing, and constant. Those words, increasing, decreasing, and constant, are describing y. So I want to look at the big picture first and decide what's happening with the y values. We're going to start from smallest to largest. So we always start at the smallest x, as far left as we can go. We're going to trace our graph. And as we trace, you can see that the y values are increasing, then decreasing, then increasing, then constant, increasing, then decreasing. So I'm going to label everything so we've got it clear. So along this section, the graph is increasing, and this section it's increasing, and along this section it's increasing. Along this section, the graph is decreasing, and this section it's decreasing, and then we have this section where it is constant. When we write our intervals, the intervals that we write down are going to be x intervals. The x's describe where the increasing, decreasing, and constant is occurring. So I'm going to bring my ruler and hold it vertically because I want to write x's down. And I want to write this interval of increasing. So we're going to start at -3. Excuse me, we're using x's, so we're going to start our increasing interval at -12. And we're going to stop our increasing interval at -10. Now you'll notice here that I'm using parentheses on both of these numbers, basically ignoring the fact that this is an open circle and this is a closed circle. And the reason why I'm doing that is because our book, when they ask for intervals of increasing, decreasing, and constant, the intervals that they're looking for are all open. Open means that you don't include the endpoints. So this is something that is related to our book specifically. Other books might be looking for closed intervals and you might have to pay attention to brackets, but in our class, you will only worry about open intervals when we're doing increasing, decreasing, and constant. So you would use parentheses on all of your answers for increasing, decreasing, and constant. So the next interval that we have is a decreasing interval. And this interval would start at an x value of -10 and stop at an x value of -6. So this x value to this x value. The next interval is an increasing interval, and it's starting at an x of -6 and stopping at an x of -3. The next interval is a constant interval, and it's starting at an x of -3 and stopping at an x of 0. The next interval is an increasing interval. It starts at 0 and goes to 3. And the last interval is a decreasing interval, 3 to 5. So once again, you'll notice that on all of these, I used parentheses, and it's because our book is looking for open intervals. So there's no need to examine what's happening at these endpoints. You'll always use parentheses for increasing, decreasing, and constant in this class. So while we're looking at this question, we can also go ahead and state what the relative minimum and maximum would be. In our book, we define relative max as a change. We define relative max as a change from increasing to decreasing. So we're going to look on our picture for any spots where we see it change from increasing to decreasing. So this particular ordered pair here, you can see it changes from increasing on the left and decreasing on the right. And this spot right here, you can see that there's a change from increasing on the left, decreasing on the right. So this particular graph has two relative maximums. We have a relative max of 3 at x equals -10. We have a relative max of 2 at x equals 3. Your book defines relative minimum as a change from decreasing to increasing. And you can see here is a point where on the left it's decreasing and on the right it's increasing. And this creates that little dip in the graph, that minimum. And so you have a relative min of -5 at x equals -6. Thank you for checking out my videos. Have a great day.